Okay, good morning, everyone. I hope you all had a nice weekend. I see some people are still joining. I'll always start my lectures on time if I can, so please try to be on time. Before we begin chapter 2, which is the main topic of today's lecture, I want to first start by correcting something, a very minor thing that I said in the last class, so I want to make sure I correct it before we proceed further. And so if you remember last class from the example, we had the Ford Focus and the Honda Civic. And so we drew, so let me get my pen. Oops. So we drew a graph that looked something like this, right? So, and then we said there's a linear function for the cost of the Focus and another one for the cost of the Civic. And they intersected at a point somewhere, right? And so, and if you remember, we called this X star. And then I said this is called a break-even point. And so I want to correct that and say that it's called, so instead of break-even, please adjust that in your notes, and I'm going to correct that to an indifference point. Why is it an indifference point? Because you're indifferent between the two options at that point. And so break even looks similar actually, which is why maybe my brain sort of went there. But break even is usually used when you have costs and revenue. So in order to break even, that means that your revenue should be equal to your cost. And then maybe it exceeds your cost and you start making profit. So the point at which maybe your production means that the revenue and the costs are equal, that's usually called a break-even point, excuse me. And so we'll see that later in the course. I think it will come up. However, because here we're talking about two different alternatives and the costs of each of them, so this is going to be referred to as an indifference point. So you're indifferent between the two alternatives. Okay, so just a minor change. The concepts are kind of similar, but just to be more accurate, please correct that. Okay, so today as I said, we're going to be starting chapter 2. Now, chapter 2 is the fundamental chapter maybe in this course. It's one of the most important chapters, if not the most important chapters. And we're going to be spending quite a bit of time on chapter 2. I think in the syllabus, at least, I have it planned for like 4 lectures, 4 classes. We'll see how we go. Maybe it's shorter, maybe it's a little bit longer, but there are a lot of slides to go through. But also, I want to make sure that you all understand that this is like a very important chapter, and that if something is not clear to you, if you don't understand, especially the parts in the beginning, then please either ask questions, come see me, just make sure you understand the content of this chapter, because going forward, most of the course, if I remember it, is sort of a variation on a central theme or a central formula or a central topic, which is the content of chapter 2. So if you understand chapter 2, chances are you're going to be fine in the rest of the course. It's the same concept but presented differently each time. If you struggle with chapter 2, then that means you need to maybe put in some additional effort to make sure you have this chapter covered properly, and then you will be set up for the remainder of the course. Okay. So chapter 2 is called time value of money. So if you remember last class, and as a bit of a review, I'll mention that we touched upon this. We said at the end of last class that we have 4 fundamental principles of engineering economics or engineering economics. And we said that the first one was that $1 today is always worth more than $1 later, a year from now or 2 years from now. And so this actually relates to something called the time value of money. And so one of the main objectives of this chapter is to see what this time value of money means. And if you remember, we said, we kind of answered it already. We said, why is $1 today worth more than $1 2 years from now? We said because of 2 reasons. One is that if you have the money now, you can actually invest it, so you can grow it. So the sooner you can get your hands on the money, the more beneficial it may be for you, generally speaking. And also, things get more expensive. So the things that you can buy with $1 today, you can buy more things today than you can with that same dollar a year from now because things are going to be more expensive. So you're losing purchasing power, and we'll see that today, actually. And so this is a very fundamental concept, and almost everything in this course revolves around the time value of money. So hopefully by the end of this chapter, you understand what it is, what its implications are, etc. And we're also going to learn something very important. Again, we're going to be using this throughout the course, something called a cash flow diagram. Right, and so we're going to recognize its components, and hopefully we're going to be able to plot cash flow diagrams for problems. And we're going to see what this means. If you don't know what it means yet, it's fine. We're going to see it. And then we're going to talk about interest. We said interest in Arabic is fa'ida or fawaid, and there are different ways of calculating interest. And so we're going to see what those are and the role that interest plays in the time value of money. And finally, these 2 points are kind of related. They relate to the concept of economic equivalence. What this means is that there are certain cash flows. So certain, in the problems that we'll be talking about, sometimes you're given 2 different scenarios. And you need to understand how to make a decision between those 2 different scenarios. And so one way of doing that is to try to compare things on equal footing. And so we're going to see how we do that. Just know that this is a concept that's called economic equivalence. So we're going to basically answer the question, when are 2 different cash flows equivalent? Now, if you don't know what cash flow means, if you don't know like what equivalence means in this context, don't worry. Just make sure to revisit these at the end of the chapter, and hopefully you understand what each of them means. If you don't, then that means there's a problem somewhere. Right, and economic equivalence has formulas and relations that we'll go over and that we'll cover. And so we want to make sure that you know how to derive them maybe in some cases, or at least know where to find them and how to use them, which is more important. I don't think we'll be focusing on the derivation a lot. Okay, so again, at the end of this chapter, you can come back to these and see if you understand all of them, if they make sense to you. That means you kind of know like the content of this chapter well enough, let's say, or at least you have some basic knowledge about the contents of this chapter. All right, so first things first, this chapter actually starts off with an example, and so let me actually do a poll. So first of all, I'll explain the context and the setup of this example, and then I'll do a poll just to see what everyone thinks. So Mr. Freeman has won the lottery. If you don't know what lottery is, it's Ya Nasib. If you still don't know what that is, you can just substitute the word lottery with the word prize, right? It doesn't matter. I'm not going to spend time explaining what the lottery is. Just know that it's a prize, right? It's a big prize. It's a big sum of money, and it's worth 25.6 million. Which is just a large amount of money. And they told him in order to receive this prize, you have 2 different options. The first option is to take $13.5 million now. The second option is to take the full amount, the 25.6 million, but you're going to be given this amount in installments. We said installments is aqsat, so he's going to be given 25.6 over 30 each year for 30 consecutive years. Okay? And so this is what the situation looks like. Option A, sorry, is a lump sum, which means it's one amount of money that you're given, and you're given it today at year 0. So Mr. Freeman is going to receive 13.5 million in option A today. Option B is the installment option, and so he's going to be receiving, so this is 25.6 divided by 30, which is just what you would expect. And he's going to receive that over the course of 30 years. From 0 to 29, that's 30 years total. So now think about this for a minute, and I'll give you some time to reason. And I want you to choose which option you would prefer if you were presented with this with this situation. Okay, so I'm going to make a poll. Which option would you choose? It's just A or B. I want you, so I'll say one thing. So there's no correct answer here necessarily. I just want you to have a reason for why you chose your choice, because we're going to be, based on the results of the poll, we'll see how we're going to proceed further with this example. Okay, so starting the poll. Okay, I'll give you a little bit more time. Fairly interesting so far. Really interesting, in fact. And I'll share with you the responses in a little bit. So we have 6 more students. If they're not asleep, if they're here, Please make your choice. 5. Okay. Not gonna wait for those 5. Oh, I saw someone I think just switch their answers, which is kind of nice. Okay, so I'll show you the responses. So if you see, we have pretty much an even split between option A and option B. Now that's very interesting. Like people who selected option A may be wondering why people selected option B, and vice versa. And so what I'm going to do, I'm going to try something actually. And so, yes, Mujtaba?
I think money now is better
let me interrupt you, Mujtaba.
Yeah.
If you're gonna say a reason, hold off on that for a second.
Okay.
If it's a question, please ask. If it's a reason, just wait a second, because I want actually students to, because we have a split response, I want students to discuss with each other what they think. So hold off on that and share that with your fellow students in a little bit. Okay. So I'm going to end the poll. I'm going to try using this breakout groups feature. Unfortunately, like I can't. It's hard for me to select. Well, ideally, like if this were in person, I'm going to pair you guys up. One student who answered A and one student who answered B, and I want you to discuss because I want you to hear the other person's or the other point of view. However, I'm going to randomly assign you to groups, and so I'll just do 17 groups. So mostly groups of 2 and one group of 3 attendees. How do I, randomly assign? I think this should do it. Yeah. Now, unfortunately, because I can't do this manually, so that means that some students are going to be in groups of 2 where both students have chosen the same option. That's fine, but in that case, think about why you might choose the other option. If the 2 students have chosen different options, please discuss with each other, and I'll give you a couple of minutes. I want you each to hear each other what you guys think about this problem. Okay, so hopefully you all had a chance to at least talk with each other and share your opinion about this problem. And so I'm just curious. I'm gonna do another poll just to see if anybody would like to change their opinion, and then we're gonna go further. I'm gonna take this example a little bit further and see what you all think. So I'm gonna end the breakout group session now. Yeah, hopefully you had a chance to talk with your fellow classmates. If you haven't, don't worry, but hopefully you did. And so now I'm gonna do.
Okay.
Okay, yeah, so the session ended, so now I can hear all of you. And so I'm gonna make another poll just to see if it changed. Again, there's no correct answer here. I'm just curious, like what happened, if anything. So which would you choose? A, B. Let's see. Okay. Interesting. Okay. So I'll show you the responses. Most people have responded. And so we actually have more people switching to A than B, which is fairly interesting. And we're gonna talk about why this happened. So hopefully you had a chance to hear from your classmates. Now, I just want maybe someone to share why you would choose option A, for example, over option B, and then I want someone to share why option B would be the the preferred option. And so before we do that, of course, notice that, I mean, this amount is kind of half the total prize. And so those who chose option B, at least, maybe, and like I'll wait for you guys to respond first, but I think it's obvious why you would choose option B, maybe because the total amount that you're getting is exactly 25.6 million. So you're not, excuse me, you're not losing anything. And also it's almost double the amount here. So it's kind of obvious why you would go for option B. If there's another reason that you chose option B, please do share, and I'll give you some time to share. Okay, so it seems like maybe what I infer from the silence is that most students who chose option B chose it because the total amount is just greater, much greater, in fact, than the 13.5 million of option A. Okay, so option A is a little bit more interesting. So can someone tell me from the students who answered option A, why did you choose that option? Yes, Mushtaba, now's your turn. Go ahead.
I think because in the long term, the value of the money in the future may decrease. So the 25.6 it will be maybe it will be the same value as the 13.5 in the future, or maybe even less, because it's 30 years.
Yes.
Also,
and someone else. Yes.
30 years is too much. Maybe I will die. So will not benefit from the prize.
That's true. That's a good point. Yeah. If you really care about money and you want the money before you die, then that's a very good point.
30,
So
yeah, 30 years is too much.
yeah. So completely understand that. Yes, Badr.
13 million can invest it and add more money than 0.8 every year. If you have like a big investment, you have to wait 2 years, 3 years to get the money, then maybe the investment will go away.
Yes. So that's another good point, which is kind of in line with what we said last class. Yes. Go ahead, Khalid.
I just assumed that I will get that I will invest it and get 5% interest, and multiply it by 30 years, I will get more than 25.6.
Okay, so you already jumped ahead and you did the calculation, so that's good. Muhammad?
Yes, Victor. Based on a quick calculations, that if you want to get 25.6 millions out of from this 13.5 millions, then for 30 years you have to get 15% revenues yearly for 30% to reach the 25.6, and this is without considering the inflation that will happen to the 13.5 million, while the second option will be less affected by the inflation.
Okay, so most of you, or some of you, are already doing calculations, so that's good. Maybe you already know the course better than I do. So all good reasons. And finally, Saleh, you're the last one, and then I have to move on.
Yes, Doctor. I think if I take it now to invest it, it's better to take option B, because if I invest it the 13.5 million, it's guaranteed that after 30 years it's 100% interest. So it's better to take option B.
Wait, so you're saying it's better to take option B than A?
Yes, because it's guaranteed that I will get 100% interest if I take option A and invest it. It's not guaranteed to take 100% interest. So I took option B.
Oh, okay. So I see. I think I see what you're saying. So just to reiterate, so students can understand. So you're saying that if you take option A and invest it, you're not going to be likely to double your money in 30 years. Yes, and so option B for that reason is better. Okay.
Yes, guaranteed.
Okay. So all of these are very good reasons, even for choosing option B. That's completely fine. As I said, there's no correct answer here because I haven't given you enough information, and some of you already noticed that. Those who did calculations, you kind of already have a sense of what to do here, but I haven't given you enough information actually to make a choice. However, what's important about this example is I wanted to hear both sides' arguments. I wanted to hear your opinions. If you chose option B, like Saleh did, for example, why? And we said it could be the total, just the total being much, you just compare two numbers, 25.6 versus 13.5. Could be because, as Saleh said, that the investment maybe will not grow enough. And so maybe that's why, again, you would choose the total. Other people chose option A because they can invest this 13.5 million and it will grow. They assume it will grow. Some people said that money is going to lose value. So if you take option B, for example, these payments at the end of 30 years are going to be worth much, much, much less. And so all of these are very valid reasons, and I'm glad that you guys all can see them and can see both sides now, maybe, hopefully, by hearing from your fellow students. And so to make this a little bit more interesting now, or just maybe to take another poll for the sake of doing polls. So let me actually switch to PowerPoint. Okay. So what happens if this is 1 million? Right? I'm doing something like very extreme here, but I just want to see. So again, I'm going to do another poll. And so I'm not going to write a question. You guys know what the question is by now. And so would you choose A or B? Okay. So mostly in line with what I expected. Just wait for a couple more students. Okay, there are 6 students who are not responding. That's fine. Okay, so I'll just share what I have at the moment so I can move on. So most people chose option B. And that makes sense to me, right? Because, well, I'll tell you the reason, I guess, or let me just continue. So most people chose option B, and that's kind of what I expect, okay? Now, one more thing. So let's suppose this is 23 million, let's say, instead of 1 million and instead of 13.5 million. Again, hopefully this is the final poll. Which one would you choose? Okay, a few more students, maybe. Okay, one more. So we just have the same amount of responses as last time. Okay, great. Oh, we actually had an extra response come in. Okay, so most people chose option A. So what I did there in those two extremes was I made the problem a little bit more obvious, right? And so what happened there? Let's see. So when I put it as 1 million, the difference in the amount between 1 million and 25.6 million made you almost ignore any effect that time might have, right? All of you mentioned reasons sometimes related to time, right? Inflation, for example, investments. When it was 1 million, it was just obvious that the difference in the amount, the total, is just far greater than anything. Like some people actually chose option A in this case too, which means maybe they're super confident about some investment that will give them 24.6 million more dollars in 30 years, or maybe even more than that. So if you know like such investments, please do share with the rest of us. I would like to know as well. But generally speaking, it's very clear that 1 million, even if you invest it, it's very hard for it to get you 25.6 million like total in 30 years. And so you opt for option B because it is the sum total of the money is just far greater, and it makes more sense to do that. On the other hand, when this is 23 million, the problem becomes obvious in a very different way. The amounts are now very close, but time is what matters here, because if you have 23 million and you can invest it, even if the return from your investment is going to be fairly low, you're still going to make a decent amount of money, hopefully, and you can probably exceed the 25.6 million given by option B very easily. You may end up with 30 million, 40 million after 30 years. So then it makes more sense to move to option A. So notice here that, so I'll switch to a whiteboard actually, just to draw something. And so on the one hand, so let me just see how I organize this. So let me write here option A amount. So this is the amount that was either given by the problem or that I specified. So on one extreme, we have the 1 million. And then on the other extreme, I think it was, I forgot how much I put. I think it was 23 million, but it doesn't matter, like the exact amount. So these are two extremes, roughly. I mean, you could make this 25.6 million. It would be even more obvious in that case. And here's the choice that most of you made. In the 1 million case, you chose option B. And then in the other case, in the extreme, you chose option A. And finally, here's sort of what I'm going to add to this. I'm going to infer what you were valuing in each choice. So when you chose option B, when I put 1 million, the amount, the total, so amount total, mattered more for you guys, because the amount was just so much bigger when you chose option B than when you chose option A. Whereas here, you're valuing time a little bit more. The timing of receiving the money is a little bit more important when the amounts are kind of close. So these are two extremes. Now, of course, the example was given with 13.5 million, which is somewhere in between. And judging by the results of the poll, it was not obvious which one you should choose. We had pretty much an even split in the class, because it's not clear which one, like how these two relate. Which one should you value more here? It's kind of some weight, some combination of these two extremes, but it's not clear exactly how you should do it. And so that's why, like even here, it's not obvious, and that's why we had a split, because people's preferences, people's interpretation, people's reasons, they changed, and that's why we had pretty much 50-50. Okay? The question we're kind of asking, in order to answer this part here, the question that we're kind of asking ourselves is the following. How can I put value on time? You know, this one is measured in dollars. This is easy. Time is not so clear. Ideally, I would put value on time, hopefully in dollars or in currency, and then I can sort of combine these to come up with a number maybe, and then I can make my decision. Something like that. That's kind of the goal here. I'm kind of like talking a little bit abstractly, but hopefully you see where I'm coming from. And so I'm kind of asking the question, is the extra X dollars worth waiting 30 years for? So this is when I choose option B. Right? So in this case, you're asking, so in this case it was 1 million. Option B's total is going to be 25.6 million, so 24.6 million difference. And so you're asking, is this extra $24.6 million worth waiting 30 years for? And in this case, it's kind of obvious. The answer is yes, because it's just a huge difference between 1 million and 25.6 million. What about in this case? You're sort of asking yourself this question, whether or not you realize it, and then you're answering it somehow. So you're saying, is the extra 2.6 million, right? Yes, $2.6 million worth waiting 30 years for? And there, most of you said no, because I'd rather take what I can right now, the 23 million, invest it, and I will get even more than that extra 2.6 million. Somewhere in the middle is the interesting case. And you notice here what happens is, if you compare the two extremes, at some point something has to switch. There is a point at which these two alternatives become equal, maybe. And where have we seen that before?
On the Honda Civic and the Focus example.
Yes. So because you're moving from one extreme where you choose B to another extreme where you choose A, at some point, right, if I make this 2 million, you will still choose option B, I think. Most of you would, at least. 3 million, 4 million, 5 million, and then it starts to get a little bit, maybe, I don't know, a little bit icky. Maybe 6 million you would still, but when I get to 10 million, it's again similar to 13.5 million, you're not sure. So at some point the switch happens, it's just not clear how to quantify or how to exactly pinpoint where the switch from option B to option A happens. Similarly, if I go, like if you put 25.6 million, it's going to be obvious that because the amounts are equal, time plays a very important role, and you should choose option A. If I do 20 million, you may still choose option A. But again, some point in the middle, the switch happens, and it's not clear why. And this is what we're going to be spending our time doing. It's trying to put a time value on money, and then using it to compare alternatives. Because as we said, so that's enough for this part. I'll just the value of the money, or the value of a sum of money, depends on two different things, and we saw that in the example, right? And so A is the amount, the total amount of money that you're expecting to receive, but B is also when you receive that amount of money. And those two things are kind of interacting in a way, and we need to understand that. And we saw in the example both factors at work. And in one alternative, in one extreme, one factor mattered more than the other, and in the other extreme, the other one mattered a little bit more. And so to make comparisons in these sorts of decision problems, we have to be able to compare the value of money at different points in time. So if I ask you the following question, do you want to receive $200 today or $150 today? What are you going to choose? Hopefully the answer is obvious, and you're going to choose the $200 today. The $200, right? Why? Because I'm giving you the option of choosing two different amounts of money, but they're at the same time. So time does not play a role in my decision. Remember, we said one of the principles is that if you're making a decision between different alternatives, and if something is the same across those alternatives, we can ignore that. It's irrelevant. So because the time at which I'm giving you these amounts is the same, it's very clear which one you should choose. You should choose the greater amount. On the other hand, if I ask you the question, do you want to receive $100 today? Okay. So if you want to receive $100 today, or if you want to receive $100 after 2 years, here the amount is the same, but the time is different. And so hopefully you all see that here today should be my choice for the reasons that we said, because you can invest it, and it's not clear that that if you get the same amount after 2 years, it's going to be worth less because everything is going to be more expensive, right? We have inflation. So it's very clear that taking the money today is always better. And you might die, as someone said, so it's always better to take the money today, especially if the amounts are equal. It's very obvious. What the lottery question, sorry, here I have some pen over the words. What the lottery question was asking is something a little bit more vague. It's changing both of them. It's saying, do you want to receive $200 today or $225 after 2 years? So the amount is different and the time is different. And so it's a little bit more difficult to compare somewhat. And that's kind of what we are going to be doing. We're going to hopefully give you the tools that you would need to compare in a situation like this and come up with your decision. Okay? So obvious when one of the factors is the same and the other one is different. However, if both factors, if the amount and the time are different, then it's not so obvious what to do. And so what we need to do is somehow put things on equal footing in order to compare them. And so we're going to take this amount here, and if we can somehow value this amount in today's dollars, then it's an easy decision, right? Because I have this amount in whatever today's dollars are, and then I can compare today to today very easily by just comparing the amounts. And so we're going to reduce a sequence of payments or benefits and costs to a single point in time, and therefore we eliminate the time factor a little bit, and then you can just compare the amounts of money directly and choose the one that makes more sense. If it's profit, just choose the one that maximizes profit. If it's cost, choose the smaller one. We're coming later. And so why does money have a time value? So Badr?
Doctor, all the examples are today and period like area. There's no period and period. All of it.
What do you mean?
Like you receive today, you receive 2 years. Are we gonna choose about 2 years and 3 years?
I see. Yeah, I see what you're saying. Yeah, the alternative, can be like. Yeah, I think your question is, what about, like, for example, if someone asks you, do you want to receive $200 2 years from now versus $250 10 years from now, or something other than today? Is that your question?
Yes.
Yeah, so you can, yeah, we will be able to also compare those types of alternatives. It doesn't have to be today. Today is just the more obvious one, like as a motivating example, but you're absolutely right. It can be anything different. And we're going to see, like, we're going to generalize that to something called a cash flow. And a cash flow can be anything. It can be even multiple payments. Like one alternative might have $200 2 years from now, and then $300 5 years from now, and then something else 10 years from now. That's one alternative, and the other one can be something similar. And we're going to be able to compare those. We're going to like do more general examples later. Right now, it's just simple examples to motivate the problem. Okay. And so why does money have a time value? And we already kind of touched on this. We said because money can earn more money over time, right? If you have money now, you can invest that money and it will get you more money over time. And that's sometimes called the earning power of money. Money can earn money, so it has some power. And also because your purchasing power changes over time. If I give you $100 today, you're going to be able to buy, let's say, a certain amount of stuff. If I give you that same $100, the same bill, 5 years from now, you're not going to be able to buy as much with it because things are going to be more expensive, and therefore your budget is not going to allow you to buy as many things as you would have bought today. And so because of these two reasons, money has a time value. Okay? How are we going to measure it? We're going to measure it in something called the interest rate. So what is the interest rate? It's usually just a percentage, let's say 5%, and some of you already know this. And we're going to apply it every year, let's say, or every period, and add it to the money. So for example, so let me say I give you $100 today. If you invest it in something that gives you 5% back every year, then by the end of year one, let's make it 10% since I already know the numbers and it's easier to do that way. So if it's 10% a year, at the end of year one, you will get $110, right? It's just the amount that you invested plus the extra $10, the 10%. You can also take that 110 and then do the same thing again, and that will give you $121 at the end of 2 years, right? So this is 1 year, this is 2 years. So that's what interest is. You can think about it as rate of return. If you want to, especially if you're thinking about it from an investment perspective, which is what I did here, right? So this is investment. You put the money down and then you get some profits. And so this is what interest is. It's just a percentage that is added to an amount of money over a number of years. Now, a very important point, and I think someone in the other section maybe brought this up on Teams. When you first see the word interest and you start thinking about faida or fawaid, an alarm starts going off, right? A red flag, which is, I mean, are fawaids halal? Are they haram? Should we be dealing with this? So I'll take this opportunity just to mention like a big disclaimer at this point in time. It's not my position to tell you if this is halal or if this is haram. However, of course, if you want to know, you should ask the proper people. You should ask people who deal, either religious scholars or people who deal with Islamic finance, that sort of thing. They know, like, because we have fawaid here in Saudi. I'm not sure how they do it in order to be Sharia compliant. So I don't have the knowledge, unfortunately, related to that. So if you're interested, you can ask other people who are more knowledgeable about this than I am. However, because I mean I have to teach this course and you have to take it, and this is unfortunately how the world works. We're going to leave aside all the religious and moral arguments about interest. So just accept it or just go with it. If you don't accept it, even you don't have to accept it. But you still have to know how the world works, especially if you end up like landing a job in a very capitalist economy like the US or Western Europe or China. Interest is going to come up a lot. And even here, as I said, we do have it. I'm just not sure how they do it exactly, or if it's really Sharia compliant or if it's not. That's a different question. So again, just I want you to be aware of this. If you're not, if you're not aware that interest may be a little bit icky religiously and you care about that, then I want you to be aware. However, unfortunately, this course is not the proper forum for discussing whether or not this is halal, this is haram. Okay? So what is interest? So just to give you an example of what it is, let's say we have two people. So this is like the simplest form of interest. So I have two people here. I don't know why their fingers are like this. That's how that's like the best drawing I could come up with for a person, or maybe just no fingers at all. I don't. Anyways, so let's say we have Khalid, and we have Osama. So let's say Khalid wants a loan. He needs money for something. He wants to buy a car. He wants to get into a project. He needs money for whatever reason. He's going to come to Osama. Or actually, even better, I'm going to replace these with foreign names because they deal on interest more often than we do. So I'm going to assume that this is John and this is Will. Okay? And so let's say John goes to Will and says, I want some money. Will says, okay, I have lots of money. How much do you need? John says, let's say he needs $1,000. $1,000. Will's going to say, okay, I will give you that $1,000. However, assuming they're again in an interest-based society, in a capitalist, pure capitalist economy, or relatively like more pure than what we are, then Will's going to say, I'll give you the $1,000. That's fine. But I want it back in a year, maybe. And John says, okay, that's fine. I'll give you it back in a year. Will's going to say, when you give me that money back, I want a little bit more. So I want the $1,000, which is the money that you're supposed to give me back anyways, plus 10%. 10% is actually a little bit high, but I mean, it's easy to calculate, I guess. Okay? And so why does Will do this? And we're going to see that it's for a number of reasons, actually, in the next slide. And banks do this too, by the way. So if this is not Will, if this is a bank is going to say the same thing. If you want a loan, you're supposed to take the money and then you pay it back with fawaid, right, with interest, with some specified percentage. And so money, like really, if you have, so John here is the borrower of the money. If you haven't seen this word before, borrower, so he's the one who takes the money, whereas Will is the lender. He's the person who has the money and who's giving it. And so interest really is a cost, right? This extra 10% is really a cost that the borrower has to pay to the lender. The lender, for him, this is just profit. This is just money he's getting extra. He's getting his original money back plus a little bit more, right? So that's the basic form of interest. That's what interest is, and that's how it came about. And so here's the example, but now with a bank. So again, it's the same thing. You go to a bank, you ask for a loan. He's going to charge you some interest rate, 8%. And so when you return the money to the bank, you're going to have to pay the principal or the original amount plus whatever extra interest rate that the bank has charged you. And so as we said, it's kind of like a rent. It's kind of the cost of borrowing money. So you're kind of renting the money, right? A loan is kind of, you can think about it as a rent. So you're kind of renting the money for a little bit, but then you have to pay a rental fee, right, for using that money. And a lot of financial institutions do this. Why? For a number of reasons. Like, for example, just administrative fees that they need to cover. So that's why they need that profit. It could be just pure profit, which is why interest even morally sometimes becomes questionable. Like you're kind of exploiting the person who needs the money, and you're saying, I want to profit off of your misery. So that's where maybe even morally it can get questionable. And also because of inflation. Again, we said like if for example, the borrower is going to return the money 2 years from now, 3 years from now, that money is going to be worth a lot less. And so the bank or the person who's lending the money has to account for that. And that's why you have to pay a number that's a little bit higher than the number that you actually took. And it can also be opportunity cost. Opportunity cost is always the cost of the alternative that you're not choosing. So when you make a choice, you're losing out on something. Right now, for example, you're taking this class, you're hopefully listening to my words. You could be playing video games. That's a cost. So you're willing to sacrifice that cost in order to be here, to attend the lecture, to get the attendance points, whatever reason you're here for. Okay, and so sometimes this is an opportunity, like it's called opportunity cost, and the reason for that is because you're missing out on some opportunity in order to choose something. And why is opportunity cost part of interest? Because the bank can say, you're taking this money from me, I could be investing that money, so I could be profiting from that money. So if you're going to take it, Mr. John, then you better like make it worthwhile for me. So when you pay me back the money, like get me some profit, bring me some money in addition to the money that you're supposed to bring back anyway. And so here's a little example about how inflation and earning rate or interest rate and like an investment, how they can interact. So let's say you have $100 today, and let's say a refrigerator also costs $100. Now today you have the money for the fridge, so you can go ahead and buy the refrigerator. You're going to be broke. You're not going to have anything left in your bank account if you do that. However, you're able to buy the refrigerator. Now let's suppose you're kind of smart maybe, or you're trying to be smart, and you invest your $100 today. And whatever place that you invested in, let's say it gives you 6%. So a year from now, you're going to have $106. However, at the same time, things get more expensive, and that's what we call inflation, right? So the inflation or atabakhum is what is the phenomenon of things getting more expensive with time. And so let's say the inflation rate is actually 8% in this case. So a year from now, even though you have $106, so you actually grew your money, it's actually worth kind of less because you can't even afford to buy the refrigerator that you could have afforded to buy right now. However, if the earning rate, let's say, is still 6%, but the inflation rate is lower, then you're actually better off, right? Because you have $2 extra if you wait a year. So in this case, delaying the purchase there may be like some economic sense in delaying the purchase for a year, because if you do it at year 0, you're going to have $0 left over. If you wait for a year, then you're going to have $2 extra left over. And it's also an important principle that whatever investment that you make should be at least as good as the inflation rate. So it should keep up and ideally exceed the inflation rate, because if not, then you're basically losing money because things are getting more expensive faster than your investments can keep up with them. Okay, and so this is kind of an important principle. However, of course, like investing here, even though 6% is lower than 8%, is still better than nothing, but it's not good enough, let's say. And this is just the same example graphed, so I'll just skip this, but it's saying basically the same thing, that you have $2 extra in case 2, whereas in case 1, you're actually losing purchasing power. You're losing $2. Cash flow diagrams. So if you remember from the objectives, we talked about cash flows and cash flow diagrams. And so what these are just like graphical representations of cash flows. What do I mean by that? Well, in order to draw a cash flow diagram, we draw a horizontal line, and we put the periods on here. So these could be years. Normally, I think we're going to be using years, but in some examples, in some cases, these may be months. How do you choose whether it's years or months? It depends on how frequently the interest is applied. So if the interest is applied yearly, so if you're given something like 5% per year, then that means you should use years as your periods. Okay, generally at least. And so the periods are going to increase from left to right. So time 0 is today, and then this is a year from now, 2 years, until n, whatever n is. N is going to be dictated by the problem. And we're going to use arrows to indicate cash flows. And these arrows are either going to go up, like this. That means this is money coming into you. So if I give you $100 2 years from now, so because I'm giving it to you, it's boosting your income. The arrow is going to be pointing up, and you can just put the amount here. On the other hand, of course, if it's money leaving your account, then you can put the arrow pointing downwards here, for example. And here, for example, you're paying $300, right? So this is just a nice visual way of seeing what money is coming in, what money is going out, and also when. So again, we're incorporating the amount and the timing of receiving a payment or of paying that payment. Now, an important thing to note, or just to keep in mind, hopefully it's obvious, is that a cash flow diagram is dependent on the point of view of like where the money is coming from or who the money is going to. What I mean by that is the following. If Ahmed, for example, borrows $5,000 today and must pay it back over the next 5 years in equal amounts, for example, you could draw the cash flow diagram like from the perspective of the lender or from the perspective of the borrower. So here Ahmed borrows, so here Ahmed is the borrower. So from Ahmed's perspective, he's getting $5,000 today, because that's a loan, and then he has to pay it over the next 5 years. However, from the bank's perspective, if the bank is the lender, the bank is losing or is giving out $5,000, so that's why this arrow points down, and then the bank is hopefully getting that money back plus interest over the next 5 years. So it depends again on whose perspective you're drawing this from. Generally, it will be clear which perspective to use. Sometimes you're just given like one perspective, and you should follow the perspective of the problem. However, in some cases, if you do something different, that's completely fine. Just be clear on what you're doing. So if you're drawing it for whatever reason from a different perspective than what the question is suggesting or asking for, just be clear that this is not from the given perspective. This is from the other perspective. Okay? So someone's cash in is somebody else's cash out. That's like how transactions work. What is a net cash flow? When we do these diagrams, sometimes you will have cash flows, for example, that look like this. So let's say you have here money in, and also money out here, money out here, money out here, maybe just a little bit. The arrows, by the way, are normally drawn in relative to the amount. So the length of the arrow is going to be, so this amount may be smaller than this amount. That's how we normally draw them. And let's say we have another arrow here. So what net cash flow means is that for each payment, since you know you have some positive and some negative, you can always get the difference, right? Net here means Safi. So whenever you have plus and minus, you can always compute the difference. And then if the difference is positive, you can just ignore this and adjust the length of this as necessary. So the length may be smaller because you have to subtract from it. Similar thing here. And so again, let's ignore these, and maybe then this is the net cash flow at that time period, right? For the other ones, it's just one direction going either up or down, so you don't need to do anything with them. Right, so it's always useful to draw it with the net cash flow because, I mean, you don't need to have a plus and a minus at the same time period. So here's an example. I just kind of gave you one, but if you want something with numbers. So let's say you make an investment of $10,000 today, and the investment will get you uniform, meaning it's the same revenue every year. So uniform annual revenues means you get the same revenue every year. And that amount is $5,000. And you're going to get that for 5 years. But you also get a salvage value. Maybe the investment is like buying a machine. So at the end of the 5 years, you can sell that machine, and you will get $2,000 for it at the end of 5 years. However, you also have to pay $3,000 a year at the end of each year to operate and maintain that machine. Badr, yes?
Salvage means sale?
Yeah, so salvage is usually used like to, at least in industrial engineering, when you sell something at the very end of its lifetime, usually for a smaller amount than what you purchased it for. But you get something, you salvage. I'm not sure like what the Arabic word is, but you're getting something for like an amount, so you don't lose it for zero, basically.
Yes. Thank you.
Okay. Right, and so as I said, we have to pay $3,000 each year for maintenance. And so if I were to draw the cash flow diagram, I would first of all indicate the investment, which is money leaving my pocket. So this is $10,000. They didn't put the amounts here. Oh, well, they put them here. So you can do it either way. You can just write it here, for example, like they did, or you can put them on the arrows. That's completely fine. And then each year we said we were going to get a revenue of $5,000. So I can indicate that, right? They used R for revenue, and they put $5,000 on every year. And then at the end, you also get an extra $2,000. So they increased the end arrow here by $2,000. Right? So they added S for salvage. S is $2,000. And each year we said we're going to have to pay. Therefore, the arrow goes down because it's payment, $3,000 a year for each year until the end of the 5 years. Right? Now, if I were to convert this into a net cash flow diagram, which is what you should normally do, like all the cash flow diagrams or most of them should be converted, I can just subtract. So at this time period, I have, what, 5,000 coming in, and I have 3,000 going out. So the difference is 2,000 coming in. And so that's why you see here, this is the net revenue, which is R minus E, and you get 2,000. Okay? That's all there is to it. Now we're just going to be defining some terms that are common in any transaction that involves interest. And we kind of already mentioned some of these, but this is going to be fundamental going forward. The first one is the initial amount of money that you either invest or that you borrow or that you loan out. That's called the principal, right? And we're going to denote the principal by the letter P. And so again, this can be like the initial investment that you make. So in this example here, you can refer to this as P. So this here, let me draw it so make sure everyone sees it. Because this is the initial amount that you're investing, which is the $10,000. That's P, that's the principal.
Is that the same as capital?
Yes, I guess. Yeah, you can use them, I think, interchangeably, at least in our context.
Okay.
And then the interest rate, which we talked about, usually we'll use the letter I, a small I for that. And that's the rate, right? It's the rate of return on your investment. It's the cost of borrowing money, as we said. And it's usually expressed as a percentage per period of time. I gave you some examples earlier, like 5% per year. This is how the interest rate is normally going to be given in problems. Each period of time that we're considering is called the interest period. And we're going to use little n for that. And so little n is going to be, let's say, if our investment is going to last for like 30 years, so little n can go from maybe 0, which is today, 1, 2, 3, all the way up to 30. Depending on how you count it, maybe it's 29 if you're including year 0. It depends. But roughly speaking, these are, so each period that we're applying interest, again, each period in the cash flow diagram is going to be called an interest period. How many of them are there? Well, it's usually capital N. So I can replace the 30 here by capital N. And so this is normally given by the problem. Usually, like for investments, maybe you invest, sometimes you invest forever, but sometimes you invest and then after a certain number of years, you want your money back. So you want to withdraw the money. And so N is going to be the number of years that you're investing the money for. And then in cash flows, we saw that we had all these arrows. Some of them go up, some of them go down, you know. And so they represent an amount of money that is either received or paid at each year. And so those are going to be our A sub n's. So A sub n, so A sub 1, for example, A1 is going to be the amount that is either paid or received, depending on the direction of the arrow, in interest period 1, for example, in year 1. And then A sub 2 is similarly, but for year 2, etc., etc. So these guys here, so this here is A1, this here is A2, and so on. Okay? So normally when you draw them, we don't really realize that this is called A1 and A2. But if you want to describe them, like if you want to write down what each of them equals, you'll write down A1 equals to 2000, for example. A2 equals to 2000, etc., depending on what values you have. That's what the A's are. And sometimes they may be just equal payments, like in this example that we just saw. And then finally, the future amount of money is basically the following. So if you invest your principal, if you invest Ras al-Mal, P, and you receive some interest, then after a certain number of years, you can withdraw some future amount, right? And that future amount represents the money growing, hopefully, after you apply interest in each of the capital N time periods. So maybe just I'll give you a drawing here. So if you invest a certain amount here, and maybe after 30 years, you're going to withdraw it. So this is called F. And sometimes F can actually be anything. It can be something here in between. And in that case, you will see something like, so for example, if this is time 0, and then time 1, time 2, time 3, you'll sometimes see like F2. So what F2 means is that it's the future amount of your principal P, which you're paying at time 0, after 2 time periods. If you don't see an N or like a subscript, then maybe it just means like at the very end of the investment, right? So F equals maybe F30. Okay, so it's just the future amount, which is just computing how much your money has grown if it's an investment after applying interest to it at each of the interest periods. And this will become clear with examples. So if you don't understand these quite yet, when you see examples, it will come naturally, I hope. Something to note. By the way, okay, should be fine. I hope you all are seeing my slides. For some reason, the stop sharing button has went gray. But but hopefully you all see the slides. If you don't, let me know. An important thing to note here is that the interest rate that we're going to be using, we're going to assume that these are taking into account inflation already. So if I tell you that the interest rate is 5% per year, that means you can safely take your money, take your P, right, if it's $100, and just grow it by 5%. You don't need to worry about inflation. It's already factored into the 5%, unless we state otherwise. You can generally assume this unless it's otherwise written in the problem that you have to account for inflation differently. Okay? And we're also going to assume that any cash flows that are indicated on the diagrams are the actual dollar amounts. So if I tell you here you have an incoming sum of, let's say, $10,000, that means you're actually going to be receiving $10,000, $10,000 cash, for example, a year from now, right? So this is the actual amount. It may be worth less than it actually says in today's dollars, again, because of the time value of money. So for example, maybe I'll just give you a clearer example. Forget about this. So let me say you invest $100, and then a year from now, right? So this is 1 year from now, you take that money out and you see $105, right? So what this means here, the 105, is you're actually going to get two bills, one with $100 and one with $5, right? Now we know from time value of money that this 105 is worth less, maybe, or roughly the same, depending on the interest rate, as $100 today. So if the interest rate is 10%, we already know that $100 today is going to be worth $110 a year from now. So this is actually worth less than $100 today, even though the number is higher. However, it's important to note that this amount is going to be the actual bills, the actual dollars that you receive. Okay? Okay, here's an example. So let's put these into an example, and hopefully things become a little bit more clear if they're not clear. So let's say a student applies for a loan. So the student needs money, and the loan is for $30,000. Okay? And the bank says, I can give you this loan, but you're going to have to pay me 9% interest per year. All right? In addition, the bank is going to charge a $300 loan fee today, like when the student gets the loan today. So they're not going to get $30,000 full. They're going to get $30,000 minus $300 because that's a fee that they have to pay to the bank immediately, right? So when the loan begins. And the bank says you have two options in order to repay me or to give me my money back. One option is you can pay equal payments at the end of every year for the next 5 years, so, right? So this is an installments plan. This is Aksat. Another one is just you pay one time at the end of the 5 years, right? And this is called a deferment plan. So to defer means you like postpone something, okay? And so basically you either pay it every year over the next 5 years, or you just pay one single payment at the end of the 5 years. Those are the two options, and the student has to choose a plan. So let's look at this in a table before we look at the cash flow diagram. So these are the years. So this is today, year 0, and then a year from now, 2 years, and then at the end of 5 years, okay? In one column, we have the money that the student is going to receive. So this is from the perspective of the student, okay? So keep that in mind. So this is money coming in. These are receipts. And so year 0, he's going to receive the $30,000, but he's going to have to pay immediately in both plans. He's going to have to pay the loan fee, which is $300, right? And then the bank does some computations, which you don't have to worry about at the moment, and finds the following amounts. In plan 1, which is like paying in equal payments over the next 5 years, you're going to have to pay these amounts, or this amount every year for the next 5 years. In plan 2, you just pay this amount at the end of the 5th year. Those are the two options. I'm not sure if we're actually going to solve this example now. I don't think we are. But we're going to see how we can compare now these two options. It's very similar to the lottery example, right? We had a lump sum and we had installments, and we wanted a mechanism for comparing them. And so that's what we're going to see in other examples later. But so this is the breakdown of this example, so hopefully the picture is clear. Now, if you want to draw the cash flow diagram, it's going to look like this. Year 0, today, he's going to receive $29,700. Why? Well, here's what's happening. he's going to receive the $30,000, but he has to pay the $300 in the fee, in the form of the fee to the bank. And so the net gain is going to be $29,700, and that's why this arrow goes up, because he's still getting money. It's a loan after all. And sometimes, by the way, on these diagrams, we just indicate the interest here, just to be clear. And then for plan 1, at least, for the equal payments, every year the student is going to have to pay the amount that's indicated in the table. Again, how we compute those, we're going to see, but for the moment, just accept it. And so he's going to have to pay this amount in year 1, 2, 3, 4, 5, until the end of the 5th year. Okay, so hopefully, you all are following, and you know how to construct a cash flow diagram. So you take the words of the problem and then you convert it into this nice visual, which shows you where the money is going and when. Now we're also going to assume something else. So what we're going to assume is that we used interest periods, or the word interest period, to denote when the interest is applied. And so in our cash flow diagrams, we had 0, 1, 2, 3, 4, etc. Now the actual cash flows, let's say this period is a year. You may have cash flows that look like this, for example, throughout the year. So in January, for example, you receive a certain amount of money, then you receive less of it in February, I don't know, and in the middle of the year, you receive this sum. However, the assumption here, or the convention that we're going to follow, is we're going to assume that all the cash flows that happen inside a period happen at the end of the interest period. Okay, so we're going to take all of these and we're going to sum them, we're going to add them, and then we're going to put one arrow at the end of the period, which is what we saw here, right? It's always one arrow. We're going to assume that everything that happens between, let's say, 0 and 1 is actually happening at the end. Now, of course, this is an assumption. Like, in order to accurately model the problem, sometimes you need to actually consider what's going on in between. But for our purposes, we're going to simplify things and just going to assume everything that happens during a year is actually going to happen, or is going to be modeled as if it were happening at the very end of the year. Okay? Just something to keep in mind. Okay, now we're going to talk briefly about, and I'm not sure how much time, or if we're going to have time to cover both types, but we'll see. So we're going to talk about two different ways of calculating interest. So the first way is called simple interest. Okay, and what this means is that you're charging the interest only to an initial sum of money, only to P, the principal amount. So, for example, year 0, year 1, year 2, etc. And so let's say I invest $100. If the simple interest rate is 10% per year, so this is 10% per year, then if the interest is simple, again, what I'm going to do is I'm going to compute the interest based on P. So this is P. This is the initial amount, remember? And so it's going to give me $10, right? 10% of 100 is $10. So my interest here is going to be $10. So I'm going to write the total here, which is 110. Now, here's where the difference is between simple and compound. If it's simple, for the next year, you're still going to get only an interest on P, so only on the principal amount. So you're going to get an additional $10, so it's going to be 120, sorry. Why? Because the interest does not care about this additional $10 that you got here. Because it's simple, you have to go back to P and compute 10% of P and then add that every year. Okay, so hopefully this is clear. In the compound case, it's a little bit different. So again, I'm just going to write the numbers underneath year 0, year 1, year 2. So if I invest $100, and if the interest rate is the same, but now it's compound, in the first year I'm going to get the same amount, right? So it's just 10% of P, 10% of the principal. But now I can actually take the additional interest, the additional $10 that I earned, and reinvest it as well. And so I'm going to earn interest on the 100 plus interest on the additional $10. And if you compute that, it's going to give you $121, right? And so the difference here is that in year 1, you're allowed to invest the additional interest that you gained if you have compound interest. If you have simple interest, it always follows the first year. Like the interest is always computed based on the first year only. In general, we're going to be dealing more with compound interest. So you can always assume that you can take the interest and, again, apply interest to it. That's how our formulas are built. Unless we state otherwise. If, for example, I want you to explicitly find a simple interest, then I will say so. But normally we're going to deal with compound interest. A funny thing about compound interest, I think it was Einstein, he said that compound interest is one of the most powerful forces in the world. So even though he's a physicist and he studies forces, he thought that compound interest was just like a very big force in the universe. This idea that money can bring you more money. And so again, like here, you're earning money and then you're earning money on the earnings, and you can repeat that and your money will grow very fast. And this is what's most frequently used in the world out there. It's usually compound interest. Okay. Here's finally an example with numbers. And so the first part, or the first example, is on simple interest. And so you have P, which is the principal amount. So let's say this is a savings account. So you're going to deposit money in the bank, and the bank is going to invest it for you, and it will give you some interest rate I. And you're given also N, a number of interest periods, right? And so let's assume that you're investing $1,000. The return on the investment, or the interest rate, is 8%, and the investment is for 3 years. We want to find F. Remember what we said, F. So if I draw this, if I draw the cash flow diagram, it will look something like this. So you're depositing $1,000 at time 0. So this is 0. And then this is 1. This is 2. And at the end, this is 3. And at time period 3, you want to take that money back. You're withdrawing the money. That's why it's a positive here, right? So this is 3 time periods, and then I is equal to 8%. So this is what the cash flow diagram looks like for this very simple example. And if you remember, I told you like sometimes F is at the very end. So it's the future amount of your investment after you apply interest to it for 3 periods. And now let me erase this so you can see the table. So this is a tabular form. You can draw the cash flow diagram. You can use the table. And so here in year 0, your balance is just going to be the $1,000. That's today. A year from now, you start with $1,000, but now you need to compute 8% of P, 8% of the interest, 8%, sorry, of the principal amount that you invested in time 0. And if you do that, you're going to find that it's $80. And so at the end of time period 1, you have the original 1,000 plus the $80, which gives you 1,080. Now again, because this is simple interest, you cannot earn money on that additional 80, right? And so you start with $1,080, but the interest is going to be the same. The interest amount is just going to be based on this value here. So it's 8% of 1,000, so it's going to be the same, $80. And you can add these two numbers up, you get this. And then again, here, the same thing. Interest earned is always going to be the same because it's always based on the same value, right? And so once you do that, you find the total at the end of period 3, and you notice that even you invested $1,000 and your money grew by $240 at the end of the periods, of the 3 periods. Now, if you want to come up with a formula, hopefully you can all derive this yourself. It's very easy. What is F? What is the future amount? It's equal to P, which is the original amount that you invested, plus the interest rate, the 8% in the previous example, times P, which is times 1,000. For a number of periods N, right? So in this example, it's 1,000 plus, this is IP. This is interest times principal. This is principal, and interest is 8%. And we're going to add it 3 times. So that's why there's this N here. Okay? And so if you do this, you can compute F. And so you can substitute, and you will find the same value without having to use a table. So this is a very nice, simple formula for finding simple interest. I think since I'm out of time, that's where we'll stop here. We're going to do another example on simple interest, and then we're also going to cover compound interest in the next lecture. And we're also going to have a formula for that. So if there are any questions, please go ahead and ask. Otherwise, I will see you guys on Tuesday. Thank you.
Just a quick question. So we won't see the difference between compound and simple interest unless the periods are longer, right?
No, you can see it in the same. Let me go back to the slides. So I think I'm skipping ahead here. So in the other example that I have for compound interest, it's exactly sort of the same setup. However, because your interest can earn money, you will see a difference in the total at the end of the 3 years. So it can be the same length.
It won't be that much of a difference unless the periods are longer.
Yes, if that's right. Yeah, absolutely. Because I
Oh,
mean, it grows faster with the more
With time.
periods that you have.
Yeah.
Yes. Okay, so let me stop recording, and I'll still be here. I have office hours after this on Teams, but if you want to ask questions, feel free to do